Today we are going to discuss about the direct memory access microprocessor system. Myself is DHEEPAK. I am assistant professor in the department of DMACs. Before starting the topic, I will explain you about the overview of the subtopics that we are going to cover in this subject. First is microprocessor. We are going to see about the microprocessor subsystems. Second point is overview of the microprocessor system. Third is data transfer schemes in a microprocessor. Fourth point is DMA controller. Fifth is DMA concepts. Then we are going to see about the input-output data transfer. Then some of these types of DMA. Eighth point is way of synchronizing the data transfer. Ninth point is comparison of DMA controller. And finally we are going to see about the architecture of 8257 DMA controller. Before going to the DMA subsystem, we will see about what is a microprocessor, what are the major subsystems involved in a microprocessor. Microprocessor is a microelectronic design which is used to do multitasking operation. So this can be employed in various applications. So major subsystems involved in a microprocessor are given in this diagram. That are all the three modules. First is the core of the microprocessor is central processing unit. Then second is memory unit, and finally it is a input-output unit. So there are three major units in a microprocessor subsystems. All these three units are connected by means of these lines which are connecting all these modules together. What are all they? They are called as buses. Bus is a physical line which is connecting each and every module with one another. Why these buses are required? These buses are required for effective data transfer, that is exchange of data taking place from the CPU to the memory, similarly from the memory to the CPU unit, then from CPU to input-output unit, and input-output unit to the CPU, and finally the data can also be transferred from memory to input-output unit and input-output unit to the memory. There are buses can be majorly classified into three types. What are all they? They are address bus, data bus, and control bus. By the name defines, address bus is used for exchange of addresses from one module to other module. Next is data bus. Data bus is used for efficient transfer of data between one module to the other module. Finally is the control bus. Control bus is used for controlling the operation of all three modules. Next we will see in detail about the microprocessor system. So this is a overall representation of a microprocessor system. It consists of, as we are told, central processing unit, input-output unit, and memory, which are connected by means of bus. But what is there in central processing unit is, these are all the three major subunits which are there in central processing unit. One is arithmetic logic unit, which is used for performing arithmetic and logical operation. Apart from that, it consists of registers. Registers are the memory location where the information can be stored. Finally, it consists of control unit. This control unit governs or controls the entire operation of the system. Next, regarding the memory unit, there are two types of memory units are available. One is RAM, that is random access memory. Other memory is read-only memory. So the informations in form of data and address are being stored in random access and read-only memory. Third is the input-output modules. So input-output modules are classified into input devices and output devices. So suppose this is a system, microprocessor system, that this system has to be connected to the external device or external peripheral devices or external systems it should be connected through means of input-output ports only. So external systems will be connected to the input-output unit, and there may be exchange of data transfer from the external device to the existing device through this input-output modules. So this input-output unit serves like a gateway. So through this gateway, this device can able to communicate with the external devices or external world, we can say. So today's topic is regarding the data transfer. There should be efficient data transfer that should be taking place between these units, that is from central processing unit, memory unit and input-output unit. Thereby task, that is microprocessors can be deployed for executing various tasks. So in order to execute various tasks, there should be an efficient data transfer rate should be there between each and every module. Thereby the task can be efficiently performed in short duration. So next we will see about the data transfer scheme available in a microprocessor system. So data transfer scheme majorly classified into parallel data and serial data. In parallel data, what is happening? It consists of n number of lines where n number of information can be transferred at any given period of time, which is faster when compared to the serial data. In serial data, only one line, address lines is available from the transmitting side to the receiving side. So only at a given instant of time, only one bit data transfer takes place. Here n bit data transfer takes place based upon the number of lines. So in parallel data can be subdivided into programmable input-output, interrupt-driven input-output and direct memory access. So programmable input-output can be further classified as synchronized and asynchronous. In synchronized data transfer, in parallel data transfer and coming under parallel data transfer scheme, where n-bit data transfer takes place at regular interval of time in synchronized. In asynchronized, n-bit data transfer takes place at irregular interval of time. So next category is about the input-driven, the interrupt-driven input-output. What is an interrupt? Interrupt is nothing but any event has to occur. During the starting of the event, the interrupt signal will be enabled to a microprocessor system. Based upon the interrupt only, it can able to prioritize that the event has to be carried out. So whenever the interrupt occurs, this microprocessor system will be alert that some event will be carried out during a certain duration of time. So next category is input driven, that is interrupt driven input output. In that it can be classified into two types: single interrupt lines and multiple interrupt lines. This single interrupt line is nothing but at a given instant of time there is a single line available where a single interrupt will occur during any period of time. So any period of time only one event will take place. In multiple interrupt lines, that means it consists of more than one interrupt lines. Thereby that is simultaneous interrupts can take place. So that means simultaneous events can occur. Finally, we are coming into our topic of direct memory access. So this direct memory access is the latest trend. Why we are going for direct memory access is because we want to transfer a bulk amount of data from an external device to the system and from the system to the external device. So the bulk amount of data can be efficiently transferred in short period by means of direct memory access. When compared to direct memory access, the performance of the direct memory access is far better when compared to interrupt-driven input-output as well as programmable input-output. So this is the latest trend that we are going to adopt. Next we will be discussing regarding the direct memory access. So you can see the block diagram of direct memory access controller. Generally, we have shown the overview of the normal microprocessor system or a microcontroller system. It consists of three major modules. What are they? One is central processing unit, which is called as a microprocessor system itself. And apart from that, it consists of a memory and a input-output unit. The input-output unit will be connected to the peripheral devices. Normally, there will be DMACC controller will be absent. During the data transfer taking place from the peripheral device to the memory location, each and every time it has to request the microprocessor or central processing unit system to respond. Thereby, bulk amount of data cannot be transferred, so data transfer time will be higher. To overcome this drawback, we are going for a advanced level of data transfer rate, that is direct memory access. In direct memory access system, we are deploying a supplementary controller, that is DMA controller, you can say. That is, or DMAC controller also you can say. This DMAC controller will be taking care of this activity. So a DMAC controller will be placed in the system, which will help the peripheral device or the input-output unit to access the memory at better rate. What it will do, that is DMAC controller will help to bypass the central processing unit or a microprocessor unit. Thereby, the input-output unit can directly get connected with the memory unit. Thereby, efficient data transfer to and from the memory can take place at a given period of time. So bulk amount of data in form of gigabytes can be transmitted. Initially, what is happening when DMAC controller will be connected to the system, this peripheral device which is connected to the input-output system will place a request that DMA activity can carry out or not. It will request the DMAC controller. So in response to that, DMAC controller will send the acknowledgement, DMAC acknowledgement to the peripheral device. After which there will be a direct communication taking place between the memory and the peripheral device. Here the central processing unit or the microcore of the microprocessor system will be neglected or bypassed, we can say. So some of the concepts in DMAC is listed here. It allows the device to transfer the data directly to and from the memory without any interference of the CPU. Next is, it is designed by the Intel to transfer data at faster rate. Next point is, the transfer of data between a faster storage aids such as magnetic disk and the memory is often limited by the speed of the CPU. Finally, final part is removing the CPU from the path and letting the peripheral device to manage the memory bus directly would improve the speed of transfer. This transfer technique is called as direct memory access technique. This same concept has been picturized in this method. That is, normally we can see that already available systems where programmable input-output based data transfer takes place. Each and every time an input device has to be, where a peripheral device will be connected to this input-output device. This input-output device will have to communicate with the central processing unit, and the central processing unit will alert the memory, after which there will be an exchange of data transfer taking place between this memory and the input-output device through CPU. But in case of the modern DMA controller, what is happening? We are introducing a DMAC controller in addition to the already existing central processing unit. This DMAC controller will help to bypass this CPU. Thereby, there will be a mutual communication taking place between the input-output unit to the memory unit. Thereby, there can be a exchange of data transfer taking place at an efficient manner in short duration of period. Next, we will see that there are DMAs, how they are categorized. They are categorized as sequential DMA, that is direct memory access, as well as simultaneous direct memory access. You can see that this is an overview of a microprocessor system. It consists of various peripheral units, peripheral 1, 2 and 3, which are connected to the system, to the input-output system. What is happening in sequential means, sequential direct memory access, the data transfer takes place from the peripheral device, one followed by the next, then followed by the third peripheral device. That is sequential manner the data transfer rate takes place. And in case of simultaneous data transfer, which is more efficient than case of sequential data transfer, because at a time only one peripheral device can able to transfer the data. In case of simultaneous data transfer, at the same time the three peripheral devices can able to transfer the information to the memory unit, as well as it can able to copy some data from memory unit to all the three peripheral devices. So in this way, the simultaneous direct memory access system is more efficient. So modern systems adopts simultaneous data transfer technique. Next, we will discuss about the way of synchronizing the process of data transfer from the peripheral devices. There are some of these already existing process which are there for data transfer taking place from the memory to the input-output device. One is polling. Polling is having the faster response, but at some certain period of time only few amount of data, that is in KBs, kilobytes, it can able to transmit. In case of interrupt approach, we have already seen what is the interrupt. Interrupt will occur, only some event has to be taken place. So interrupt will be triggered to the microprocessor system. The response of the microprocessor system is, it will give the priority to the interrupt. It will stop the regular activity and it will give the priority to the interrupt. Thereby the interrupt will be acknowledged, based upon which the event can be carried out. But in this way also, compared to the polling method, this interrupt approach is faster, better. But when compared to both the things, that is polling as well as the interrupt approach, direct memory access is a significantly complex system to understand, but it is having better transfer rate, time consumption will be less. Next, we will see that what are all the commonly available direct memory access controller in the recent trend. There are two major types of direct memory access controller. One is 8257 based DMA controller. Other is 8237 based DMA controller. So when we compare both, what is happening? You can see that memory to memory data transfer rate is not allowed in case of 8257, but in case of 8237, the memory to memory data transfer rate is allowed. Next one is, it can able to transmit only 2 to the power of 14 bytes for a given period of in a single channel. But here in 8237 it is far high, that is 2 to the power of 16 bytes can be transmitted. Third difference is cascading is not allowed, that is expansion of the channels is not allowed in case of 8257, but it is allowed in case of 8237. Fourth difference is, you can see that data transfer rate is only 500 kilobytes per second for 2 megahertz of clock. Here in 2 megahertz of clock, that is better data transfer takes place, that is 1.6 megabytes per second takes place. Finally, we will see about the fifth difference, that is, it has more number of internal registers in case of 8237 when compared to 8257. So there are two major, recently we are using deploying 8257 and 8237, but most advanced is 8237. Next we will see the architecture of a 8257 DMAC controller. We are not going to, we will see in brief what and all it consists of. Majorly, any DMAC controller consists of channels. Here you can see that there are 4 channels are available. Channel 0, channel 1, channel 2 and channel 3. So here these channels only will take care of DMAC request, placing the DMAC request, and based upon which the acknowledgement will be getting acknowledgement. So you can able to place, that is from the external device, the request will be placed to this channel and it will acknowledge to the external device. So it consists of 4 channels, channel 0, channel 1, channel 2, channel 3. Apart from that, it consists of data bus buffer, which is having the address lines from D0 to D7, where data transfer takes place through this read-write logic, where read and write operations can be carried out. Finally, the overall operation is being managed by means of control logic and mode set register. So through this internal bus, you can able to manage the overall channels, read-write logic modules as well as the data buffer module. Apart from that, it consists of supplementary module, that is priority receiver. So whenever the interrupt occurs or some priorities has to be triggered during that time, this will be this flag inside this priority receiver will be set. So other important key features of 8257 is primary function is sequential memory access, which allows the peripheral to read and write data directly to and from the systems. Apart from that, it has we have discussed that 64 kilobits of data transfer takes place. So this DMAC controller can play as two major roles. That is, it can play as a slave as well as master. When it is in slave mode, what is happening? Input output data transfer takes place from input output to the memory to the microprocessor system. When the DMAC controller plays as a taking as a master role, what is happening? Data transfer rate takes place from the processor to the peripheral device. So this is today I have given you the overview of the direct memory access controller. This can be employed in latest technologies and latest applications. Thank you.